Hello friends, today we're going to talk about exponential growth and decay. Our learning target: represent and solve problems in various contexts using exponential functions such as investment growth, depreciation, and population growth. Here is a formula we'll be using. A of t equals little a times 1 plus or minus r to the power of t. If it is increasing, we're going to be adding r. If it is decreasing, we're going to be subtracting r. And then to find r, you want to do the percentage and divide by 100. They're going to give us r as a percent. The rate is a percent, but we need it as a decimal. So we will divide it by 100. And then t is the time. So let's look. A $12,500 car depreciates. Depreciates means it's decreasing or it's decay. It's going down 9% each year. So little a is our starting value, 12,500. R is our percentage divided by 100. So 9 divided by 100 is 0.09. Our equation, a of t equals our starting value. Since this is decaying, we're going to subtract 1 minus 0.09 to the t. And then if we simplify that, we get a of t equals 12,500 times 0.91 to the power of t. And then the value after 5 years means we're going to take 5 and plug it in for our t's here. So a of 5 equals 12,500 times 0.91 to the power of 5. This is money, so we're going to round to 2 decimal places. You'll put this part in the calculator. And our final answer then, $7,800.40. So if you buy a car for $12,500, after 5 years, the car will be worth $7,800.40. A baseball card bought for $50, so that's our little a. It's our starting value. Increases means we're going to add. And then our rate is 3%. So it starts at 50. We'll do our percentage divided by 100, which means our r is 0.03. So a of t equals 50 times 1 plus, because it's increasing, 0.03 to the power of t, which simplifies to a of t equals 50 times 1.03 to the power of t. And then to figure out how much this baseball card is worth after 5 years, we'll plug in 5 for t. So a of 5 equals 50 times 1.03 to the power of 5. And again, we'll put this part into the calculator. And our final answer then, again, it's money, so we'll round to 2 decimal places, $57.96 it will be worth after 5 years. The population of Hillville grows at an annual rate of 15%. It grows, so it's increasing. Our R, or our rate, is 15%. What will the estimated population be in 5 years? If we look here, it says that it originally is 5,000. So our starting value is 5,000. Our rate, 15 divided by 100, is 0.15. So our function then, a of t equals 5,000. It's growing, so 1 plus 0.15 to the power of t. And then simplifying that, A of t equals 5,000 times 1.15 to the power of t. And again, they're asking for the value after 5 years. So far, all of these we've been plugging in 5, but you can plug in any number for t. So A of 5 is 5,000 times 1.15 to the power of 5. This is people, so we're going to round to the nearest whole number. So this is going to be about 10,057 people. The value of a painting increases, so we're adding by 37% every year. If the painting was purchased 17 years ago for $14,385, how much is it worth today? So the original value was $14,385. Our percentage, or our R, 37 divided by 100, is 0.37. So our function then, A of t is 14,385 times 1 plus 0.37 to the value of t, or to the power of t, which then simplifies to A of t equals 14,385 times 1.37 to the power of t. And then the value after 17 years, so we're going to plug 17 in for t here. A of 17 is 14,385 times 1.37 to the power of 17. So if you buy this painting for $14,385 after 17 years, if it goes up by 37% each year, this painting is going to be worth $3,035.68. Whew, that's a lot. So get another painting. The value of a painting increases, so it's going up by 59% every year. If the painting was purchased 12 years ago for $13,375, how much is it worth today? So it starts at $13,375. To find our R, we'll do 59 divided by 100, which is 0.59. So our function then, A of t equals 13,375 times 1 plus 0.59 to the power of t, which then simplifies to A of t equals 13,375 times 1.59 to the power of t. Now we want to know how much it's worth after 12 years. So we'll plug in 12 for t. A of 12 equals 13,375 times 1.59 to the power of 12. After 12 years, this painting will be worth $3,491,879.78. A computer valued at $6,500 depreciates at the rate of 14.3% per year. So it starts at $6,500 or $6,500. Excuse me. It depreciates, which means it's decaying. We're going to subtract. So our equation here starts at 6,500. If we do 14.3 divided by 100, we would get 0.143. Our equation then, A of t equals 6,500 times 1 minus 0.143 to the power of t, which gives us a of t equals 6,500 times 0.857 to the power of t. So let's see how much this computer is worth now after 5 years. Since it's depreciating, I know that my final answer should be smaller than 6,500. So I'm going to plug in 3 for my t's here. A of 3 is 6,500 times 0.857 to the power of 3. And if we put that in our calculator, we would figure out that the value of the computer is $4,091.25. All right, one more. The population of a certain animal species decreases at a rate of 3.5% per year. You have counted 80 of the animals in the habitat you are studying. Write a function that models the change in the animal population. So it's decreasing, it's going down. We're starting with 80, and our rate is 3.5%. Let's put that as a decimal first, or it already is a decimal, but it's in a percent. Let's change it. 3.5 divided by 100 is 0.035. So if I wrote my equation, a of t equals 80 times 1 minus, because it's decreasing, 0.035 to the power of t, which simplifies to a of t equals 80 times 0.965 to the power of t. And it says, estimate the number of years until the population first drops below 15 animals. So to do that, we have to put this in our calculator and just kind of guess and check, plug in different numbers for t until our final answer is below 15. So if I look at Desmos here, put in my function, 80 times 0.965. I'm just going to pick anything to begin with. I'm going to say to the power of 10. Well, that still has 56 animals, so it's going to take way longer than 10 years. So now I'm going to look at 20 years, let's say. All right, there's still 39 after 20 years. So now I'm going to change my exponent to 30. All right, there's still 27. I'm going to change it to 40. All right, now it's 19. Let's see if I go to 50. Ooh, it's 13. So I know it's going to take over 40 years, but less than 50 years. So now my next guess is going to be somewhere between 40 and 50. I'm just going to choose 45. There's 16 animals left after 45 years. Let's see, after 46 years, ooh, almost less than 15. After 47 years, it's finally going to drop below 15. So again, I just guessed and checked. I just put numbers in and kept checking until my answer was less than 15. So it's going to be about 47 years. All right, so the big things to remember, make sure with R that you turn it, or that you divide it by 100 to get the actual value of R, and make sure that you're looking at keywords to determine whether the function is increasing, which is exponential growth, or decreasing, which is exponential decay.